Okay, this is what you should have gotten. Thumbs up if you got that. Raise your hand if you have a question. Okay. All right, now moving on to the other part, dilution. Okay, dilution is the process of making a solution. What do you think? What is a dilution? What is the process of, like, why do we do it? Less concentrated. Okay, this is usually done by adding more solvent to the solution. Okay, I've given you many real-world examples already so far. So we're going to look at these two beakers. So A and B. So just looking here, you can clearly see that one has more solvent than the other, right? So beaker A, would you say that this has a high or low molarity? High, which would mean B has a low molarity, okay? How did we go, and I just said it, how did we get from this high molarity to this low molarity? What did we do? We add H2O, which is our solvent, okay? So what you can interpret from this is, if my molarity is high, what do you think your volume is? Low. If my molarity is low, then my volume is high. Okay? So they should be opposite from each other. So we just said which of these solutions is more concentrated? A. Which of these is more dilute? B. So we usually use molarity in the dilution problems as it is the most common way to express concentration. When we add more solvent, we decrease the concentration of the solution, which decreases the molarity of the solution because, again, molarity is a concentration value, and makes the solution more diluted. Okay, so this formula is your formula for dilution. V1 M1 equals V2 M2. We have voom voom. It's just a way to remember it. Okay, not that you have to have it memorized because it's right below your molarity value. Okay, so that's saying volume 1 multiplied by molarity 1 equals volume 2 multiplied by molarity 2. Now, if this equation has 4 variables, how many variables will I give you? 3, which means you have to solve for the 1. Okay? Or maybe I give you 2, but you have to use one of them to find the other one and then keep on going with that. Okay? So, the hardest thing about dilution problems for students that I normally see is just figuring out which one is the V1, V2, M1, M2, okay? Now, I'm going to read this problem and then I'm going to kind of show you a trick. So it says, what is the molarity of a solution of NH4Cl prepared by diluting 50 milliliters of a 3.79 molar in a NH4Cl solution to a final volume of 2.0 liters? Now, I will tell you, and you guys should know this by now, a lot of the problems that we do in our notes are sometimes, most of the time, easier than what you see on your test. I'm not going to have something that says final volume, okay? Whenever you see a molar value or a volume value that are sandwiched in between of A, okay, of A, what that means is that they are together, meaning they are either your V1 M1 or they are your V2 M2. Does everybody understand? That of A is telling you that they are together. Okay? So, this 50 milliliters would be what? Is that my V1 or my V2? V1, which would mean this is my M1. And obviously here, saying final volume tells me that is my V2. Okay? Now, what do you notice about my V1 and my V2? They're different units. Now, What was our unit for molarity? Liters. Dilution, it can either be milliliters or liters. How you know what value to use is all dependent on what the first volume unit was. Did everybody hear that correctly? The first volume unit. So if my V1 was in milliliters, that means my V2 must be in what? Milliliters. So this is not 2.0 liters, it's 2,000 milliliters. Okay? Did everybody see that? Yes? No? Maybe so? Does everybody understand why I changed it to milliliters and not this one to liters? Okay. So now I plug in what I have. So 50.0, and I like to write my units next to it. It's not required, but I like to just to make sure that everything is the same unit. Okay? So now you just solve. Basically, you're solving for x, which is M2. So everybody plug that in. And for sig figs for this, we're looking at our givens, not after we've converted it. Okay, so I don't want you thinking that you need one sig fig here. You don't. You need 3 sig figs. Ashley, let me know what you get. .09, so you need 2 more sig figs, because that's only 1 sig fig right now. Good. Questions? Okay, now, hold on, before we go to the next example, because this next example kind of goes along with it. There could be questions where I could ask you about how much water was added, or you would have to use the information that I give you to figure out how much was added for that second volume. Okay? So if that happens, if you see something about H2O added, okay, all you do is it's the difference of V1 and V2. So if there's ever a problem where you have to figure out what was added, that is how you would do it. It's the difference of V1 and V2. Okay? So let's do this next example. A 1.0 liter, 3.8 molar solution of FeSO4 has 7.0 liters of water poured into it. Okay, what is the molarity of the new diluted solution? Okay, now this one, however, we're not going to be subtracting anything. We actually, to figure out the V2, what would we have to do? We'd have to add what we have because it said it was poured into it. So this 1.0 liter, is that my V1 or my V2? V1. This 3.8 molar is my what? M1. This 7.0 liter is not my V2. Okay, to find my V2, I have to take my 7.0 plus 1.0, and that gives me my 8.0 liter, which is my V2. What is the new molarity? That is my M2. Does everybody see how I got the 8? Are we sure? Because said it was poured into it. Okay? So, 1.0 liter times 3.8 molar equals 8.0 liters M2. Everybody plug that in. Yeah, because I don't think I have any extra notes. I have scratch paper right behind you. At the bottom. Mm-hmm. Hayden, what'd you get? Say it again. Perfect. If you put a 0 in front, that's fine. It's not significant, so it's not really needed. Questions? All right, I want you to do this next example on your own. This is what you should have gotten. If you have questions, let me know. So, stock solution, okay, that's a word that you need to make sure you're familiar with, okay? The stock solution, you have to dilute, okay? That is what we get in whenever I was talking about how we order chemicals. We consider those stock solutions, okay? That's what the chemical companies give us that then we dilute down, okay? So just FYI. All right, any questions about this example? I'm about to move on just for time purposes. Okay, if I finish early, I'll put this back up. All right. Stoichiometry. Told you it was never going away. So we can have reaction stoichiometry when we're talking about molarity. So because molarity involves moles, we can use molarity in the context of stoich problems. Molarity can either be calculated by finding moles using stoichiometry and dividing it by liters, or it can be used as a conversion factor where a molarity of number of moles per liter can be interpreted as a conversion of number of moles equals 1 liter. Okay? Now, this right here, what I highlighted, is nowhere on your formula chart, which means, do you have to just know that? Yes, you do. Okay? So, this example says, how many milliliters of a 0.150 molar potassium iodide solution would be required to react completely with 15 grams of lead 2 nitrate? Now, before you write anything down, because, I mean, you shouldn't be because I haven't written anything down. Anytime we are doing a reaction stoich problem, what do we always have to have? A balanced equation. Yep. Not going away. I never told you it was. That's the first thing you have to do. Is, again, because anytime you see a conversion factor, that would mean that we are talking about some sort of mole to mole ratio. So, we are given both of our reactants. Can I write a balanced equation with just 2 reactants? 100%. How do I do that? Well, potassium iodide and lead 2 nitrate, are those elements or compounds? So that means both my reactants are compounds, which means what type of reaction is this? Double replacement. Okay, potassium iodide. How do I write potassium iodide? Ki. Lead 2 nitrate. How do I write lead 2 nitrate? I would be writing this down, Advait. All right. My first product is what, Janav? And my other product is PbI2. Now, what do I always have to do when I write out a balanced equation? Yes. Not states. I don't care about states anymore right here. Balance, very good. So for time purposes, 2, 1, 2, 1. All right. Now, what I'm going to do, and I know some of you will be very happy, this next part isn't necessarily required, but it is highly, highly recommended. And even though maybe on your test I'm not requiring it, highly recommending it, it is required that you write it down during class, a mole map. Okay? And especially for this, because have you ever done a problem like this? No. And there's a lot to do. With this, okay, my given is my gram value. Okay? Why is this my gram value? And not my molarity? Can I go from my molarity value to milliliters and just bypass the 15 grams? No, because this is not a simple molarity problem. This is stoichiometry using molarity, right? So it talks to you about right here. Molarity can either be calculated by finding the moles and dividing it by liters, but we don't have that. Do we have a mole value? No. Do we have a liter value? No, we have a milliliter value. So you have to start with your gram value. And I have to first go from grams to moles using molar mass. Then I can go, because again, my whole goal here is trying to find milliliters of potassium iodide. I can then go from moles, hold on, Jake, to moles using mole ratio. Yes, Jake.
Wouldn't it be 15 grams of lead nitrate, not potassium nitrate?
Oh, yeah, so sorry. Good catch. This is why you don't use pen. Well, I will use pen always. And Vidyuth will use pen always because he likes to spite me. But to moles. Alright, you guys get the gist. Good catch, Jake. My bad. Grams of lead nitrate to moles of lead nitrate. Moles of lead nitrate to moles of potassium iodide using mole ratio. Then I can go, what's my next step going from moles to milliliters? I'm not going to go back. Why would I go back from moles to grams? I need to find liters, right? I need to find liters. I have a mole value. And what other value do I have? Molarity. So then I can use my molarity value right here. And this will give me liters, and then I can go from liters to milliliters. Sorry, it's a little cramped. You'll see it better in a second. Okay? So, now when I actually set up my stoich, my given is 15 grams of PbNO3 My first step was going from grams to moles. Now for time purposes, and you guys know I don't normally do this, for time purposes I'll go ahead and give you the molar mass of lead 2 nitrate, 331.22 grams. My next step is my mole ratio. What is my ratio of lead 2 nitrate to potassium iodide? For every 1 mole of lead 2 nitrate, 2 moles of potassium iodide. So everybody plug that in. Do we see where this could go wrong if I don't write a balanced equation correctly? Yep. Vishnu, what'd you get for the mole value? So you need 3 sig figs. What? If you just hit the up button and then hit enter, it should give it to you again. Or you can just plug the whole thing back in again. That's fine. What? Well, because you're setting up a... No, you can't. Because where are you going to put your molarity value? Zero point what?
The molarity value is 0.150 m. So it's
yes.
Not 0.150 moles per liter. Can't I put that in the expression?
Moles per liter? But we're trying to find milliliters.
I mean, that's what I'm saying. When we put the
I don't want you to continue on. And I'll show you why in a second. What'd you get? 0.6. Did everybody get that? 0.6. Okay, so this is moles of Ki, okay? That's my mole value, and if you look up here, based off my mole map, now I can plug what I have, which is my 0.150 molarity equals 0.0906 over X, okay? Okay, when you do that, you get 0.604 liters, correct? But that's on our final value, okay? And you can literally just come out right here and just show that conversion, because for this, you would need to show that conversion. If you just draw an arrow from this to 604 milliliters, that will be wrong, okay? I have to see this conversion from liters to milliliters. And if you notice, and I hope that you guys always read the directions on your test where it says all work leading up to the final answer must be shown in order to receive credit. That means any sort of subtraction that you did, any sort of conversion that you did, that's all your work, right? Must be shown, okay? This is 604 milliliters of what? Yeah. Oh. You have a question?
Yeah, about the conversion of the
Mm-hmm.
milliliters. Going off of you wrote,
Oh, yeah, my bad. Oh my gosh, you guys, I'm literally on one. That's why you guys are always my tester class. I know. Who can read that? All right. Questions about this one? I want you to do this example on your own. Or you can work with somebody at your table. So this is what you should have gotten. So like I said, like I broke mine down like this just because I feel like it's easier. if you put some things together, as long as I can clearly see it, and you've shown all your work in conversions, then we're good. But your final answer is right here, okay? I will tell you, if you got this problem correct, you should, and like, you have all the work, then you should feel pretty good. Like, this is a pretty difficult problem. No, I'm not saying you're going to get 100 on the test. Some of you might. But this is more challenging, okay?